The goal was to design a heat sink that dissipates not only a lot of heat, but with the minimal amount of mass possible. So
we started out with like a good problem definition, and we identified what we needed to look at and what we needed to solve, and that allowed for a very guided approach.
We used ANSYS Fluent for our simulations for computational fluid dynamics, and we also used ANSYS Structural for finite element analysis.
That we actually compared our simulation results of a basic pin-fin heatsink to a known heat transfer correlation. So we were able to sort of take literature values and then compare it to our simulation.
And so we had to come up with strategies to actually simplify the simulations to where we could get them to run. And so one thing we did, we used quarter symmetry in our modeling. So we didn't actually model the entire thing, we just did a quarter of it.
Sort of build off of very simple heat sinks and then slowly add features one by one and figure out, okay, does this feature work? Does this feature not work?
You know, the scope of what is possible with additive manufacturing is so different than what's possible with subtractive manufacturing. It really opened up, you know, especially at the scale that we're designing for, additive manufacturing just allowed for a lot more creative freedom and allowed us to design something that wouldn't have been possible otherwise.
When we contacted GE and they got back to us, we had to actually implement supports like multiple times, multiple iterations, not just once, not just twice, but multiple times, to the point where our part was actually manufacturable. So
like, I think it's really important in a project like this to really recognize when something you're doing isn't going to work.
I think ultimately something that we all learned is that the engineering process of going through designing something, if it works, keep it, roll with it. If it doesn't work, you know, maybe take the best things from it, utilize from it, and then expand on it, and just keep going through the process until you have a solid design.